Alright, hello physics people. So today is going to be my family dinner of physics is my experiment title. So I'm going to be covering just a little bit about heat transfer and about pressure differences and how those two are kind of similar. So here we've got taco soup. So it's like it doesn't show it right now, but this off is treated to 425 degrees, which is well above the boiling point of water. So this was steaming a while ago, and one of the reasons that we even have steam is that water actually has a really high a specific heat range, so that it can absorb a lot of energy, and so it's a pretty high energy particle. So that's what escapes first when an item starts to heat up. So that's why we get steam out of stuff. Next, as far as heat transfer goes, is stuff that's at 425 degrees tends to spread pretty quick. But here we have a ceramic bowl that I can clearly hold that is not at 425 degrees, and that's because the characteristics of the ceramic bowls are that they're poor, but they're poor conductors. So it's like there's not, how would you say, there's not a lot of high energy particles in this bowl for the heat energy from the soup to actually radiate out to the bowl on that. So that's why a lot of your bowls and stuff are made from that stuff. And then second, here for heat transfer, we've got ice in our cup. So I put this ice in this cup probably 5 or 7 minutes ago, and the cubes are quite a bit smaller than they were when I put them in. And as I talked about in class, that's a good thing, because it means that the heat energy from the water is actually going into the ice cubes and is melting the ice. So it's like when you very first pop ice into a drink and it doesn't melt, well, that's because the heat energy from your drink hasn't actually had a chance to get into the ice yet. So it's not necessarily that the ice is putting cold into the drink, but it's that the drink, because it has a lower temperature or a lower amount of internal energy, is actually transferring energy into the ice and bringing its internal energy levels up, and turning it from a solid to a liquid on that. So there's our two examples of our heat transfer that you see just in daily life. And the other thing that I'm just going to cover with this is pressure differences. So something to understand about pressure is that it always flows from high concentration to low concentration if it's given a chance. That's why if you even turn on your tap water right here, then there's pressure in the line, and there's just ambient pressure around. So as soon as you provide a gateway for it by opening the tap, then that pressure is going to want to escape. So applied to the straw right here, it's a really neat thing, because you don't actually suck up stuff. You just create an area of negative pressure or lower pressure inside the straw portion, that the pressure on the water then actually starts to push its way up the straw, because right now there's equal amounts of pressure right here and right here, in this portion of the straw and in the lower portion of the straw. But as soon as you provide lower pressure in this portion, then the pressure upwards against the air that's filling up this portion of the straw is going to exceed that, and it's going to start to go up. So when you basically lower the pressure in here through basically sucking up the water, then the water pushes through the straw instead of sucking out the water. So so you guys can't see this, but Yum. So like another way to see that is if you basically close this off right here and you lift up out of the straw, kind of shake this dry for a second, then you can actually get water coming out. And that's because when gravity tries to push the water down, then gravity actually creates that area of a low pressure, because additional pressure can't fill in this space once gravity tries to pull the water out or push the water out. So like what you get is, you know, a certain amount of matter that gravity is trying to push to expand a certain space in place of the water, but it doesn't like that. So, you know, it's like, so you get pressure holding this water inside this because of because of pressure differences. So that's my family dinner of physics, and hope you guys enjoyed.